This video is meant for first year MBA students and it's going to help them in the course Quantitative Techniques or Business Statistics. I'm going to be explaining things from a very basic fundamental level so that even students who have not studied mathematics in their 10th, 11th standards are also going to benefit, right? So in this particular video, we are going to be looking at measures of dispersion, right? So basically, what are measures of dispersion? Measure of dispersion basically tries to get a sense of the data, how scattered the data is. Okay, so dispersion is the extent to which values in a distribution differ from the mean value, from the average of the distribution. Okay, so I'll try to explain this with help of examples. So the most commonly used measures of dispersion are range, standard deviation, or variance. These are interrelated because one is the square root of the other. Then we have the interquartile range, often abbreviated to IQR. And I would also like to introduce the concept of, so these are the three most commonly used one, but there is also the concept of mean absolute deviation. Mean absolute deviation. Okay, so now let's look at the data set now. So we have the original data set 2 2 3 4 5 4 5 6 8 1. So it's always a good practice to sort of arrange data in an ascending order. Okay, now there are 10 numbers in this. Let's just put it in an ascending order. 5 6 7 8 9 10. I'm not leveraging the power of Excel because in the examinations you may be required to do this using pen and paper. So therefore I don't want to use Excel shortcuts. So let's just do it in the way you would perhaps write with pen and paper in your exams. Alright, so let's identify this as arrange in ascending order. Lowest value here happens to be 1. Let's have 1 there. Then we have 2's here, 2 2's, 2 and 2. Do we have any more 2's? No more 2's. Then we have a 3. Then we have a 3. There is a 4. There are 2 4's. Okay, let's put that down. 4 4. How many 5's do we have? We have 2 5's. We have 2 5's. We have a 6 and we have an 8. So that's our data set, right? So let's just first of all look at the first measure of dispersion, which is range, right? Range is nothing but the difference between the maximum value and the minimum value in your data set. So in our data set, the minimum value happens to be 1 and the maximum value happens to be 8, right? Therefore, the range in our particular data set is maximum value here minus minimum value there, okay, and 8 minus 1, and that is 7. Okay. Next, let's look at how do we identify standard deviation or variance. Okay, so like I was explaining in the beginning, it is actually, we're trying to understand how the data is spread and how much it deviates from the mean or the middle point. So it goes without saying that we also have to find the mean for this, right? So how do we find the mean for this? Sum up all the numbers in this and divide it by the number of observations, right? So number of observations n is equal to 10, right? And let's just sum this up. Let's see what is it total of this. So total of this is 1 plus 2 is 3, 3 plus 2 5, 5 plus 3 8, 8 plus 4 12, 12 plus 4 16, 16 plus 10 26, 26 plus 6 32, 36 32 plus 8 40. Okay, sum is 40 sum of all the numbers is 40, and therefore the average, or x bar as we call it in mathematical terms, average, okay, let me also write it as x bar, is 40 divided by 10, and that is 4. So the average of this group of distribution is 4. Right? So this is, let's call this x. Okay, let's call x bar here. So please remember that even though I write it as x bar here, typically it is an x with a bar above it. Okay, because Excel sheet, so I'm just writing it as x bar. But please remember, when you write it, it's x with a dash on top, called denoted as x bar, right? So for x bar for this uh, distribution is this. Now let us try to understand uh, what is the, let's also have a place here for summing up to find the sigma. Okay, right, okay. So now the summation of this we know is already 40. We have done that earlier. Okay, so we have x bar here. Now let us see, let's try to understand what's the deviation of each of these x. Okay, we can call it x1, x2, x3, x4. Let's understand what is the deviation of each of these values from the mean, that is 1. Okay, so let's try to do that. This is 1 minus 4, that is equal to minus 3. 2 minus 4 minus 2, 2 minus 4 minus 2, 3 minus 4 is minus 1, 4 minus 4 is 0, there's no deviation, 0, 5 minus 4 is 1, 5 minus 4 is again 1, 6 minus 4 is 2, and 8 minus 4 is 4. Okay, now this is actually deviation from the mean. Let's call it DEV. Let's call it deviation from the mean. Okay, now why are we not simply summing this up and then dividing it by the number of observation to find the average deviation? Right, let's understand why we can't simply find the deviation from the mean and find an average of it. Okay, so let's attempt to do it. Okay, so minus 3 plus minus 2 is minus 5, minus 5 plus minus 2 is minus 7, minus 7 minus 1 is minus 8, minus 8 plus 1 is minus 7, minus 7 plus 1 is minus 6, minus 6 plus 2 is minus 4, minus 4 plus 4 is 0. So now if you try to simply sum up the deviation, it actually becomes 0, right? So by definition, a mean is at the middle point, and all of these observations in the data set actually differs from the mean by the mean is identified in such a way that it's at middle point. So if you try to find the distance of each of these points from the mean and sum it up, the negatives and the positives will cancel out and you will get a 0, right? So therefore you cannot simply find this difference and sum it up. Okay, so of course another method what we can do is actually we can find the absolute value of this, right? The absolute value of this, instead of taking it as minus 3, we can, let's say, find the positive value of that, and let's call it the absolute value of the deviation, dev. Okay, and that's 3 here, 2 here, 2, 1, 0, 0, 1, 1, 2, 4. Let's quickly sum this up. 3 plus 2 is 5, 5 plus 2 is 7, 7 plus 1 8, 8 plus 1 9, 9 plus 1 10, 10 plus 6 16. Okay, so this value, okay, so now we have taken the absolute deviation and now we have to find the average of that, because there are 10 observations, right? There are 10 observations, so your mean absolute deviation is going to be 16 divided by 10, MAD. MAD is 16 upon 10, which is 1.6. Okay, but for some reason mean absolute deviation is not widely used. A more popular method of measuring deviation is what is called the standard deviation, or which is actually determined in a way to offset the issue with the negative numbers which follow. Okay, so therefore we actually use a different method. We don't normally use mean average deviation in a lot of our calculations, or it's not a widely used measure of dispersion. So I just wanted to tell you why you cannot just simply find the difference from the mean and sum it up and find it. Okay, so mean absolute deviation is one of the methods, but not widely popular. So let's just look at what is standard deviation, right? So let us say earlier, so this particular value, what was deviation? Deviation was basically x minus x bar. That's what your deviation is. Okay, the deviation is x minus x bar, right? So let's now look at x minus x bar squared. Okay, let's square this. Okay, so minus 3 squared is 9, minus 2 squared is 4, minus 2 squared is again 4, 1 squared is 1, 0 squared is 0, 0, 1 squared is 1, 1 squared is 1 again, 2 squared is 4, 4 squared is 16. Okay, let's try to find the sum. 9 plus 8 is 17, 17 plus 18, 19, 20, 24, 24, 16 is 40. Okay, now okay, so x minus x bar whole square is 40. Now x minus x bar whole square divided by the number of observations we had is called variance of the distribution. Okay, so the variance of the distribution is given by summation of x minus x bar the whole square. Okay, x minus x bar whole square, sum of all those numbers divided by the total number of observations. The total number of observations. So we have 10 observations here. So you divide 40 by 10 and we get the value 40 by 10 is 4. So the variance of this particular distribution is 4. Okay, and standard deviation is defined as the square root of the variance. It's simply the square root of variance. There is no way you can directly find the standard deviation. Standard deviation is expressed in terms of it's actually the positive square root of the variance. Okay, so standard D is square root of 4, which happens to be 2. Okay, so I'll take another video to explain interquartile range or IQR. Okay, so in this particular session we have understood what is measure of dispersion. What are the most commonly used measures of dispersion? These are range, standard deviation and interquartile range. So I've also added explanation about mean absolute deviation so that you understand why standard deviation is required, why you have to square the deviation, otherwise it could just cancel out. Okay, so that's that. So in the next video I will be talking about interquartile range.